All right. Hey guys, so here's your guys' exponential and logarithmic functions practice number 1, okay? So this was number 1, which is what we did on the other day. So here we have we gotta solve for these exponential equations. So what we have to do first is we have to get common bases. And if you guys use that huge chart, right, and I'll show it to you guys, this chart right here, so you guys use this chart right here, you try to figure out how do we get these two numbers to be the same base. So 4 and 8 could be the same common base of 2. So this is going to be 2 to the second times negative 2x minus 2, and this is going to be 2 to the third times x minus 5. And because they have the same bases now, they got the same bases, then that means the two exponents have to be equals to each other. So we're going to get distribute that to negative 4x minus 4, and then we're going to make that equals to 3x minus 15. Get variables on one side, so I'm going to move my 3x to the left-hand side and get constants to go to the right. Negative 7x equals negative 11, and divide both sides by negative 7, and x is equal to 11 over 7. So there's that one right there. Number 2, so we gotta get common bases, so all of these can be 6. 36 is 6 to the second times x minus 4, and 216 is 6 to the third times 2x. So let's simplify this down. Distribute this. So we get 2x minus 8 equals 6 to the 6x. And now, so the only thing we have to do is just get this to be represented by 1 base of 6. So since it's 6 times 6, what we really have to do is just add the exponents together. So it's going to be the same base of 6. Negative 2x plus 2x is negative 2x. Minus 8, and that's equal to 6 to the 6x. They both have common bases now, so now we can set the exponents equals to each other. And now we solve for x. I'm going to get my variables to be on the right-hand side. Divide both by 8. X equals negative 1. Number 3. Okay, so for here, now with between 16, 4, and 64, we can get all of those to be the same common base of 4. Or 2. It doesn't matter, 4 or 2 would work. But I'm probably just gonna get it to be a common base of 4, you guys. So 4 to the second times negative 2x. Now this, you guys, is really 1 over 4 to the first. Now we're going to bring 4 to the first up top, but then this exponent becomes the opposite. So 4 to the negative 1, and then times the 3x minus 1, and then 4 to the third, you guys, is 64 times the x plus 2. Distribute that. Distribute this, so we really got 4 to the negative 4x times 4 to the negative 3x plus 1 equals 4 to the 3x plus 6. But remember, we got to get 1 base of 4 to be on that side, so this is multiplication. You guys just have to add the exponents together. So we got that, and now since we have common bases on both sides, we set the exponents equals to each other. So negative 7x plus 1 equals 3x plus 6. I'm going to get my variables to go on the left-hand side, and I'm going to get my constants to go on the right. So negative 10x equals 5, and divide both sides by negative 10. So x equals, now we can divide top and bottom by 5 to make it negative 1/2. So that's the first 3, getting common bases and then solving for the equation. Now we to evaluate logs. So when we evaluate logs, you guys, well, we should equal this to some x value. And then we're going to convert this from log form. And we're going to convert it to being in exponential form. So we take the base, raise it to this power, and it's going to equals to the argument, which is 32. Now, to get this, well, let's get common bases on both sides. They both could be 2. 2 to the 6 times x equals 2 to the 5th power. And since they both have the same bases, you just set the exponents equals to each other. And we solve for x. So that's going to be 5 over 6. But again, change log form to exponential form, and then you guys just solve the exponential form. Now here, since it's equal to x, again, change this log form to become exponential. The base of 9 raised to the x power equals 1 over 243. What common base can we get both of these numbers of 3? 3 to the 2nd equals 1 over 3 to the 5th. And now we should bring the 3 to the 5th up top, but it's going to be the opposite exponent, -5. Set the exponents equals to each other, and we get that x is going to equals to -5 over 2. Condensing. So when we condense, you guys, now I am going to have to bring this log to exponential later on. But when we condense, so we have to get 1 log in our answer. So let's make all of these coefficients become exponents. So log u of 5 to log of v to the 3rd plus log of w. And now when we condense it, you guys, we're only supposed to have 1 log in our answer, and because this is product rule, on the inside, all of them become multiplication within the log. So that will be our final answer for 6. Number 7, again, get all the coefficients to become the exponents. And then once we have a log minus a log, we can condense this, you guys, but it's minus, so it's quotient rule. 10 to the 8th, all divided by 5 to the 3rd. And condensing it, we should have 1 log in our answer. Now when we expand, you guys, it's a different story. So when we expand, we should probably expect multiple logs potentially. So we have number 8, so we should get this power of 2 to go to the front. 2 log base 2 of 10 times 3 times 7. And now, you guys, we expand that, but now it has a 2 in front of each log. 2 log base 2 of 10 plus 2 log base 2 of 3 plus 2 log base 2 of 7. And that's your guys' expansion. Number 9. So we have a 5th root, you guys, and if you guys recall, to change that root to be an exponent, it's going to be 1 over the index. And then put this exponent to the front using power rule. So 1/5 log of x times y, and now you guys can expand it, and since it's product, it's going to be 1/5 log of x plus 1/5 log of y. So there's 9. Number 10. Alright, so we should bring that power of 8 to go to the front. And now we can expand this because now it's division. And when we expand it to multiple logs, there's going to be a minus sign in front of the log of x. Or behind, and for the log of 8. 8 log of y. Okay. And lastly, we have solving for log equations. So there are 2 scenarios that you guys need to prepare for. You gotta get a log equaling a log. You guys gotta get log equaling a number. And if it is log equaling a number, that means you have to do log form and change it to exponential form. So for number 11, on the left-hand side of the equal sign, I see a bunch of logs. On the right-hand side, I see a number. So this makes me think I have to change log form to become exponential form. So in order for me to condense these, this 2 has to be a exponent. Log base 2 of 4 squared plus log base 2 of x is equals to 4. Now we can condense it, you guys, by using the product rule because there's a plus in between logs. So it's going to be 4 squared, which is 16, times the x. For 16x is equals to 4. So we have 1 log equals a number, right? A whole log equals a number. So now we can convert it to be an exponential form. Take the base, raise it to 4, and make it equals to 16x. 2 to the 4th is 16. Divide both by 16, and x is equals to 1. And with log equations, you guys have to make sure when you guys plug it into the original, you don't have any extraneous. You can only get extraneous when the inside of the log becomes negative. So the fact that we plug in 1 into here, log base 2 of 1, well, that's just positive of 1. So that will be perfectly fine. But again, you cannot have a 0 or a negative number inside of the logarithm. If you do, you get extraneous solution, which is not an answer to our problem. Number 12. So it looks like we have a log equals log case, you guys, because there's a log here and a log on the left and right hand side. So when we condense it, it's minus. So when you condense it, it's division. X over 2 equals log base 9 of 8. And because it's log equals a log, you guys, all we have left is x over 2 is equals to 8. Times both sides by 2, and x is equals to 16. And when we plug in this 16 into here, you guys, that's perfectly fine because of log base 9 of a positive number 16. And lastly, 13. Well, this is a log equals log case, you guys, and if we cancel those, we just get x squared minus 10x is equals to 24. Set this equation equals to 0. And we get x minus 12 times x plus 2 equals 0. So equals 12, and x is equals to negative 2. And when we plug in both of these, you guys, respectively into here, it produces positive value. 12 squared is 144. Negative 10 times 12 is negative 120. 144 minus 120 is 24. When we plug in negative 2 into here, negative 2 squared is 4. Negative 10 times negative 2 is 20. 4 plus 20 is 24. So both of these would be perfectly nice answers. Okay? So again, that's your guys' practice. So keep on practicing and, prepare well for your guys' exam. Okay? All right. Good luck, everyone. Peace.